Okay, so as in the last video, we have discussed about the fourth postulates of the Bohr atomic model theory, right? In today's video, we are gonna discuss about the radius, which was calculated by Bohr. So as you can see the topic here, today we're gonna calculate the radius, which is the distance from the nucleus of an atom to the electron, right? So as you can see here, this is the nucleus I have. This is the nucleus I have, which has the positive charge, right? So this is the nucleus, right? Now this radius is basically the distance from the nucleus to the electron, which is revolving around the nucleus, right? So for suppose here I have electron which is revolving, right? Which is revolving. Wait, let me make it circle as well. For suppose this is revolving, right? This is revolving. This is revolving. Now basically this radius is the distance from the nucleus of an atom to the electron. So this is basically the distance from the nucleus of an atom to the electron, which is revolving in the shell around the nucleus. So this is what we call the radius, right? This is what we call the radius. So this is basically the radius. Now we have read about the first equation too, which was given by Niels Bohr in his third postulate, where he discussed about the quantization condition, right? In which he said that electron will only revolve in those circular orbits in which the angular momentum is equal to the integral multiple of h by 2 pi, right? So that was our first equation. So let me write that first equation here so that we cannot forget that, right? So here I have my first equation, that was angular momentum, which is mvr is equal to integral multiple, means h nh by 2 pi, right? This was the first equation. First equation. First equation. Then in his fourth postulate, we got to know that electrostatic force provides us the centripetal force, right? We calculated that yesterday. So let me write that second equation here as well. Second, wait, let me change the color of this, or I'll highlight this, right? I'm writing with white, then I'm going to highlight. So that was equal to mv square by r, which is the centripetal force, and that is equal to the electrostatic force, which is equal to Ze square upon 4 pi epsilon naught r square, right? And that was the second equation. Second equation which he discussed in his fourth postulate, where electrostatic force provides us the centripetal force, right? Let me highlight this with this color, right? Okay, so now we have written our two equations here. The first equation mvr is equal to nh by 2 pi, and the second equation mv square by r is equal to Ze square upon 4 pi epsilon naught r square, right? So now we need to calculate the radius, right? Let me write the first equation here. Let me write the first equation here. So first equation I know it is mvr is equal to nh by 2 pi, right? Now I'm gonna let me write the second equation too here, so that we cannot be confused in anything, right? So let me write the second equation here with this color. So second equation we were having was mv square by r, which is centripetal force, is equal to the electrostatic force, and that is equal to Ze square upon 4 pi epsilon naught r square, right? Now see, here we have square, but here we don't have square, right? So mean I have to take a square of this. So I need to take square. Let me take squaring on both sides, right? So let me write here squaring on both sides. Squaring on both sides, right? So let me take the square now. Let me write with white color, then I'm gonna highlight with another color. So m square v square r square, as you can see on the left hand side, mvr, m square v square r square is equal to nh by 2 pi. So n square h square, 2 2s are 4 pi square, right? Now we have to divide this first equation with the second equation. So let me write this here. This is the most important point, right? What is this important point? Dividing first equation with the second equation, right? Second equation. Dividing the first equation with the second equation. So let's divide this now, right? Let me highlight this first. Okay. So this is highlighted. Now we're gonna divide this whole equation with the second equation, which is equal to mv square by r is equal to z square upon 4 pi epsilon naught r square, right? So let me write this here. mv square by r is equal to z square upon 4 pi epsilon naught r square. Let me highlight this as well with this color. Okay, right? Now we need to divide. Let me use the white color now. Now let's divide this equation, right? So v square is cancelled with this v square, m is cancelled with this 1m, right? And here let's see what is going to be divided here. Pi is cancelled with this 1 pi, and this r is divided with this 1r, right? What else we have? Yes, 4 will be divided by this 4. Now let's see what's remaining here, right? Let's write here now. Now we have remaining is what? R square is equal to n square h square upon pi, right? Upon pi, as this whole term is dividing, right? So I'm gonna write like this now. Divided by ze square upon 4 is cancelled, pi is cancelled, epsilon naught, 1 r is cancelled, however 1 r is remaining, right? To convert this particular division sign into multiplication, converting, right? Converting division into multiplication, right? Into multiplication. What we're gonna get will be, wait, let me highlight this too, because I don't like white color at all. Okay, so let's convert this sign. R square is equal to n square h square upon pi multiply. Now we have converted this division sign into multiplication, means there will be a reciprocal of this value, right? So we need to take the reciprocal, means epsilon naught r upon z square, right? Now see, check here, we have 1m would be left here as well. Yes, m, I just forgot to write here. 1m we have here, and m we have again here, right? M we have again here. Now see, this 1 hour is cancelled with this. Here we have 2 hours, so 1 hour is cancelled with this 1 hour, means 1 hour is still remaining. This M is multiplying here. Whenever we're gonna go there, it will be divided, right? So R is equal to, now multiply these both terms, means what we have gotten, N square H square epsilon naught by, we have pi, and M will come there and will be multiplied, M Z E square, right? Z E square. So this is the derivation. Wait, I'm gonna tell you the shortcut of the finding the radius as well. But the best thing is to learn this derivation, since if they're gonna ask you the charge is, leave the charge. If they're gonna ask you the mass is the double of the electron, or if the mass is the triple of the electron, then what you're gonna do? Because there would be a constant, right, instead of that. That's why you need to learn this derivation. Now see what terms we have constant here. We have n square, not a constant, right? Because shell number will be changed. H square is constant, which is equal to 6.25 into 10 to the power minus 34 joule second, right? And epsilon naught is constant here, whose value is equal to 8.85 into 10 to the power minus 12, right? Pi is constant, whose value is equal to 3.142. Mass of the electron is constant, which is equal to 9.11 into 10 to the power minus 31. Z is not constant because atomic number of every atom will be changed, right? However, this charge is constant of electron, which is equal to minus 1.67 into 10 to the power minus 19 coulomb, right? So the terms which we don't have constant, we're going to write those terms separately, right? So H square is constant, epsilon naught is constant, right? Down we have pi constant, M constant, E square constant, right? Into, now what's remaining up? N square remaining by, down we have Z remaining, right? Now we have changed, or we have separated our constant values and the values which will be gonna change, right? Which will be changed. Now this whole constant value is equal to, this whole constant value is equal to 0.529, or you can write 0.53 into what we have here is n square by z square Armstrong, right? So this is the shortcut. This is the shortcut, which is equal to 0.53 into n square upon not z square, however only z. Since we have not square on the z, right, we have square on n only. And n represents here the number of shell, right? Not the number of shell, but the shell number, right? Yes, shell number, and z represents the atomic number. So let me highlight this. Here we have got our shortcut, right? Now if somebody is asking you what's the radius of what's the radius or what's the distance from the nucleus to the electron of the first orbit of hydrogen atom, right? So we know that, wait, let me write here, first shell of hydrogen atom, right? First shell of hydrogen atom. Now 0.53 is the constant, which will be constant here, right? So 0.53 into n value we have already got here, right? First shell, because n represents a shell number. So 1 square is 1, and atomic number of hydrogen is what? It is 1. So 1 by 1 is 1, and 1 into 0.53 is 0.53 Armstrong, right? So this is the answer. I hope this derivation for the formula of radius is clear to you all. In the next video, we're gonna discuss about the velocity.